All species, like our own human population, have the biotic potential to establish an ever-accelerating or exponential rate of population growth. However, studies of ecosystems undisturbed by human beings show that most populations don't continue to grow larger and larger over time, but rather tend to remain relatively stable. The reason most populations don't continue to grow exponentially is that they reach the environment's carrying capacity or encounter environmental resistance in the form of severe weather, predators, parasites, or competitors. Living populations are also distributed throughout the environment in different patterns. Some organisms live in large clusters or aggregations. For example, most herbivores live in herds. Many birds live in flocks, and large numbers of fish live in schools. Other organisms, such as fir trees in boreal forests and creosote bushes in the desert, tend to be uniformly distributed in their environment, while throughout most of the year, monarch butterflies and brown bears are randomly scattered in theirs. Populations also exhibit characteristic distribution patterns over time as well. For example, in some species populations, the majority of individuals live to old age, while in others, most individuals die very young, and only a relative few survive into old age. In between these two extremes are populations in which individuals' chances of death are relatively constant throughout their life. Let's now take a closer look at the factors that affect the growth of populations and their distribution across space and over time. Three factors determine changes in populations: births, deaths, and migration. Populations grow as a result of birth and migration in, and decline through death and migration out. Populations grow when the number of births and immigrants exceeds the number of deaths and emigrants. Populations decline when the reverse occurs. Thus, the equation for population change is births minus deaths plus immigrants minus emigrants equals population change. In many natural populations, in and out migration contributes relatively little to population change, leaving birth and death rates as the primary influence on population.